Hello, good morning once again in the new session of our chemistry class. And yesterday we started the new chapter, surface chemistry. And today we are going to continue the same chapter and we will go for in detail. Just before I start the new class, I'm just going to recall your memories. I just want to make you familiar with the terms we have studied here yesterday. The students who are new here, I just want to give the introduction. For them, this is Seema Tamrika, the PGT Chemistry of Kendriya Vidyalaya, number 2 Riva, and I'm just here to help you learning online mode, right? It's just my small initiative to make you comfortable at your homes. So yesterday I started with the topic adsorption and absorption, and very mouth-watering examples I have given. And adsorption, the painted surface of this place here, right? And so many other examples are there. Charcoal powder absorbing the gas, absorption. The example were the rasgulla and gulab jamun and so many other things. And I think you all remember the pizza was also one example of the adsorption. So adsorption, the surface phenomena of depositing of any substance, any molecular species onto the other surface, and this surface is a solid or liquid. Most of the time it is the solid one, right? And two components are there of the adsorption, right? This blackboard, I think you can never forget as an example of the adsorption, right? Adsorbent and adsorbate. The surface is known as the adsorbent, right? And the material that it sticks is the adsorbate. Absorption, another phenomena, that is a bulk phenomena, right? Whenever any substance move inside to the another one, that is the absorption. Now I have is to discuss some factors affecting to the adsorption, and I have just one question to check whether you are learning or not. Please sit carefully, right? Read the question that I'm showing you here. One data I have given you, right? The name of gases are written over here, and then at the second row, the critical temperature of these gases are here. Can all of you see this? Is it visible to all of you? And the temperature is given in the Kelvin. Please take out your pen and paper. I think every day I just say that please sit with the pen paper. Definitely learning will be more here. Now, some gases are written: H2, NH3, hydrogen, ammonia, sulfur dioxide, methane, and N2, nitrogen, and their critical temperatures are given over here. And now you have to solve these three questions. Vineet, Parth, please be ready with the pen. Now you have to answer the question. Three questions. Okay, Anshika is also here. I cannot call everybody's name because I know it's going to be time taking. But good morning to everyone watching here, and please do learn with me. Solve the question. Three questions are given here. Which gas will be absorbed maximum? The second one question is the which gas will be absorbed minimum, and the third is question is you have to arrange in the increasing order of the absorption. The data is here. I'm giving you the time of 2 minutes. Very good responses. I can see some of the students writing the answers. Still, I'm showing you the data so that you can see it. Okay, 1 minute is going to be completed. Then you will get only 1 more minute. Try to write the answer. Yes, now I'm taking the question by myself. This question was based on the factors affecting to the adsorption process, and the factor that was affecting to the that was the nature of the gas. And one key factor, yesterday I told you that the gas that has the higher critical temperature gets liquefied easily, right? You all know that it's difficult to stick in the gaseous phase rather than the liquid state. Liquid gets stick easily. That's why the gas that easily gets liquefied can be adsorbed more efficiently. So here the hydrogen is having the least value of the critical, lowest value of the critical temperature, and sulfur dioxide has the highest value here, right? So sulfur dioxide will be the most efficient, will be absorbed maximum, the minimum will be the hydrogen, and the correct sequence will be H2, N2, CH4, methane, ammonia, and sulfur dioxide, right? Increasing and decreasing order. Here, Shruti has arranged it, but again, the problem every time I see in the every session it happens, you arrange the things in the proper way, but you don't know the increasing and decreasing. You have to start with the minimum to the maximum. That is the correct way of writing increasing order. Right here, one more conclusion you can come to from this question. You can see the H2 and N2, hydrogen and nitrogen, these are the atomic gases, right? In the element form they are, and there are ammonia, sulfur dioxide, and methane. These are the molecular gases, and molecular gases always have better abilities, right? You can see they have the higher value of the critical temperature, right? Now, again, I'm coming to my main points here. I think this is just one way that you will be energetic, you will be active. This is an activation energy that I have supplied. When you solve the questions, definitely you become more attentive for the learning session, right? Adsorption, basically, I have divided into the two categories on the basis of the the basis of the force by which any adsorbate gets accumulated. The accumulation of the substance on any of the surface is the adsorption, and the force that binds to them. On the basis of that, two categories were there: physical adsorption and the chemical adsorption. In the very short, I'm just going to revise it for all of you who has joined me today. You all can see physical adsorption, physisorption known as chemical adsorption known as chemisorption. Along with this, today I'm just giving you two terms, right? Positive adsorption, negative adsorption. Tomorrow I will ask about these two words. And along with this, occlusion, OCCLUSION. This is a new term. You have to search. This will increase your inquisitiveness, right? So here, physisorption, chemisorption, right? Physisorption, this is a physical change, physical phenomena. The chemisorption is a chemical change since it is associated with the formation of chemical bonding, right? Ionic or covalent bond. Here it is the van der Waals force. Non-specific in nature, since any substance can form the van der Waals force. Is specific in nature because chemical bonding is a characteristic feature of any of them. If their valencies or the chemical bonding abilities, right, they are in such a way that they can make the bonds, then only positive cannot make the bond with the positive, similarly negative cannot make the bond with the negative. So that's why it is specific in nature. You have seen the physics option was reversible. I always use the duster to remove the chalk surface, right? Chalk is adsorbent and the green board is adsorbent, while on the other hand chemis option is a irreversible phenomena, right? Since more than once the physis option may take place, our chocolates, multi-layers are there, Snickers and all these chocolates, they have multi-layer deposited over there. This is a multi-layer. Since chemis option is associated with the chemical bonding, once if it forms, one molecular layer is formed, that is the unimolecular. Low enthalpy of adsorption is required here. The high energy required here. The enthalpy of both the processes are exothermic. Yesterday I taught you that adsorption is the exothermic phenomena. Since it is associated with the formation of the bond, whether this bond is a van der Waals force or this is a chemical bonding, as it is associated with the bonding always an exothermic process, right? That's why it's an exothermic process. The energy, the enthalpy is more in the case of chemisorption, as it is a stronger bond, and physisorption the weak one. So here the energy is low, enthalpy is low. And in the case of physical adsorption, either no activation energy is required, or if it is required, then it is a very low one. In the case of chemisorption, the high enthalpy of activation is required. So this is just a quick review that we have discussed yesterday. Adsorption, the phenomena of accumulation. Two components are there, adsorbent and adsorbate, right? Now I'm coming once again to the factors affecting to the adsorption process, right? What are the factors which affect to the adsorption? One very important topic that I have to discuss is the Freundlich adsorption isotherm, and this is a part of the factors affecting here, right? One by one, I'm taking all the factors once sequence wise. The first one, the nature of the adsorbate and adsorbent, right? They must be in the way that they have one, they can accomplish the composition of each other, right? And in the case of the gas, one important parameter is the critical temperature that comes from the kinetic theory of the gases, right? One very important parameter, that is the critical temperature. By solving this type of the question that we have discussed in the beginning session today, you will must remember all this. The second is the nature of the surface also. Nature and area, both the things. I think a surface that is very smooth, right, is not very suitable for the adsorption process. For increasing the adsorption process, sometimes the surface is made rough. I think if you have seen any time whitewash session or the painting on the furnitures, you would have seen that sandpaper is used first to rub the surface and then the paint layer is applied, right? It is just to make the surface little rough so that deposition can be easy. I think you remember, if your hands are greasy, your palms are greasy, you pour some water, it falls down easily. But if it is rough, it sticks, right? Then simultaneously the area also, if it is a surface phenomenon, definitely the increase in the surface area will increase the efficiency. So definitely if the surface area is greater, larger, right, the adsorption process will be also greater, whether it is chemical or it is physical. The one very important part that I am going to discuss here is the temperature. Of course, it's the sort of the energy, it's the type of the energy, right? And energy, the very essential part of any of the phenomena, any of the thing. So one very important thing that we have to discuss is the temperature. Now it's summer days. All of you, generally, how you drink the water? You just take out the water bottle from your fridge and then you drink the water. Do you do this? Most of the time, you do this, that you are taking the water bottle from the fridge, right? You drink the water and then you leave it on the surface of table or somewhere outside, right? What do you observe? After the few minutes, you find that the water layer is the bottle is covered with the layer of the water droplets. Do you think that your water bottle was having leakage? No. Indeed, it was not the reason. Right? What has happened actually? The water droplets have absorbed by the surface of the bottle. And what do you feel? When you heat it, generally you have seen that when you are heating it, it leaves the surface. After some time, your observation, it is changed. You keep it for the longer time, what you will see that after some time, that the water droplets which were stick around the water bottle, they are removed from the surface. This is your day to day life, especially in the summer days, in the days we are having now, right? Cold drink, juice, sharbat, whatever is served in the glasses, you can just keep it before the guest, and after few minutes, you'll find that water droplets are around it. Clear? So this is just because of the adsorption process, the moisture that is present around the water in the atmosphere, they get adsorbed on the surface since it is cooled one. Have you ever seen that around the tea cup, the water droplets are like this? No, never. Right? So that means yesterday also we have discussed it is an exothermic process. The adsorption is the exothermic process. Right? So you all can come to the conclusion that the extent of the adsorption will be greater at the lower temperature if all the other variables, all the other factors are same. If the couple, the adsorbent and adsorbent are same, the pressure is same, the surface area is same, the other factors which are variable, whenever we study the effect of any of the factor, what we have to do, we have to keep all the other variables constant. So similarly here also, for this, what you have to keep constant, if you have you are going to study the effect of temperature, you have to take the same set of the weight and adsorbent. The other conditions should remain same, the surface area and all the other things, and pressure also you have to keep constant. Right? The pressure also you have to keep constant so that you can study the effect of the temperature. So what you will observe as the temperature is increasing, right? What you see that the rate or the extent of the adsorption goes down. What do you mean by this word? The one term I'm using here is the extent of adsorption. What is its meaning? Again, it is one standard parameter. How much amount of the adsorbent is adsorbed by any adsorbent surface, right? If X is the gram, X gram is the amount of the adsorbate that is going to be adsorbed on the surface of the adsorbent having the mass m, right? This X upon m, X is the gram of the adsorbate, right, adsorbed by the m mass of the adsorbent. I'm focusing on the word adsorbent so that you don't get confused. Adsorbent, always the surface, adsorbate, solute and solvent. I have compared it with that. Please do remember with that solvent, the basic water medium is there, like here also. Adsorbent is the surface on which this phenomena takes place, and the adsorbate is the substance that is going to accumulate, right? So this, how much adsorbate is adsorbed by the unit mass of the adsorbent. This is called the extent of adsorption, right? And this depends upon the temperature. Here you see the graph. Although this I have drawn for the purpose of the effect of pressure, then also we can see here, this is a graph that I have plotted. This is P, this is in the x-axis, I have taken the variable P, okay, and X upon M, the extent of the adsorption. And you can see that for the different temperature, it's different one, right? If you see the X upon M, the value of X upon M, it is different as their heights are different one here, right? At the temperature 273, the value is less, the 244, then here, and 195. I think you all can see that 195 is the lowest value of the temperature that is written over here, and for this the X upon M is the highest, right? So since it is an exothermic phenomena, as you are going to heat the system, what you will see, you will find that adsorption process is reversed, right? Desorption take place. Okay, you will see that, ma'am, here the pressure is changing, and you always say that we have to keep it constant. So, okay, I'm taking any point at this, right? If I'm going to take at this point, that means that pressure is constant here, right? For all the three temperature, at this point I have drawn, that means I am going to study only at this particular point. Here you can see these are the values for the same pressure. Now at this particular point, the pressure is not changing at all, and still you can see here that at the different temperature, the X upon M, that is the extent of the adsorption, is different. For the lower temperature, its value is higher, and for the higher temperature, its value is lower. That means from here you can come to the conclusion that the temperature is one parameter on which the adsorption depends upon, right? And as the temperature decreases, the extent of the adsorption increases. Desorption term, I think, just opposite of the adsorption. And this is also a reversible phenomena in the case of the physical adsorption. And what you observe, that equilibrium is established. I think all the reversible phenomena, they have the ability of the equilibrium also. Equilibrium is also one characteristic feature for such things. And what you see, that after certain change, there is no effect of the temperature also, right? So this is the thing here, this is the story here. The temperature is one important parameter here on which the adsorption process depends upon, and it is inversely related, right? Is it clear? Because the same graph, the same concept I have to use for the effect of pressure also, right? The effect of pressure, that is the main point, that is totally a new concept over here, right? That I have to take, and for the sake of this, I have taken all these ones, right? Some or other way, they are going to be interrelated. Clear? Okay, now I'm moving to my next factor that is going to affect the rate of adsorption or the extent of adsorption, and this is pressure. And the scientist, name of the scientist, Freundlich. He who has given the relationship, the mathematical relationship, right, between the pressure and the extent of the adsorption. Actually, what happens? What do you expect? With the increase in the pressure, the adsorption will increase or decrease? Increase or decrease? Okay, one system is there, right? Whenever at the beginning level, right, you increase the pressure, right? I think you all remember the gaseous theory, the ideal gas equation. Do you remember? PV is equal to nRT. Remember? PV is equal to nRT. Right? From here we can come to the conclusion, right? So whenever it is always and always, whenever we discuss anything with the help of graph, that means it is studied experimentally, and the science, it always goes for the experimental verification here. So the Freundlich has given the adsorption isotherm. The word isotherm means here the temperature will remain constant, right? The isotherm, in the thermodynamics we have studied different types of the system: isobaric, isothermal, isochoric. So isothermal means whenever all the other factors along with the temperature are constant, there is no impact of the temperature, right? In the case, please see the graph now, you will understand the things better. I'm plotting it to the front. This kind of the graph you obtain when you plot a graph x upon m versus the pressure. In the beginning, what you have seen here, see here, when this is the graph, it is almost up to this point, it's a linear, right? Inclined straight line graph is here. Then at this point, you find the curve, right? This is the area that is the curved one. Along with that, you find some area. I can divide this graph into 3 parts. This white part, this you can see here, as you are increasing the pressure, the x upon m is also increasing, and it is a straight line up to here. At this point, this is the straight line, right? Up to this area, this is a straight line. That means how you can correlate. In the kinetics chapter also, you have seen the relationship for the graph, that x upon m is directly proportional to the p to the power 1. There also I have discussed lots of time this graph. And here at this area, what you can see, this area that is shaded by the yellow color. What you are observing here, at this place, do you find the change? No. You all can see that this area here, it is a straight line. This is a parallel to the P, right? From this point to this point, the linear change is there, straight line change is there. Here you find the curved one, right? And at this place, what you observe that there is definitely no change, right? This area is showing the difference in the change pattern. So here the graph is not of one kind alone. It is a combined three different type of the graph, right? I'm just discussing first this part of the graph. What you observe here that as the P increases, the X upon M increases, right? X upon M is to the power 1 at this part. This is called the low pressure graph. Okay, I think you can understood here. It is pressure, is it? Don't have the sufficient space. This at high term pressure. And at the high pressure, what you observe that X upon M is proportional to the P to the power 0. P to the power 0, that means any quantity having the power 0, its value become 1. Clear? So if it is 1, that means it is non-variable, it's constant, it's fixed over here. Right? So this you observe. Why this happens actually? Whenever this is your surface, right, on which the adsorption has to take place, as you increase the pressure, what happens? Some of the area is occupied by the adsorbate, right? As the time passes, as the pressure increase, now this up to here, what we were seeing that as the pressure was increasing, the X upon M was also increasing, the area was, right, the free for the adsorption process. But now at this time, when we have reached here, what you see that some of the area of the surface is being already occupied by the adsorbate. So that means the area that is now available for the adsorption process, as it is a surface phenomena, is now smaller. And after the some time interval, this is the story for this time. After the time, there will be a condition when the entire surface will be occupied or covered by the adsorbate. Right? So definitely, if there is no available area, there will be no change in the X upon M or the extent. Right? So here, what you have observed, as you have increased the pressure at the beginning, right, what you have seen, an inclined graph has been obtained, right? A straight line graph, you can equate it, X upon M is equal to K, a proportionality constant, right, P to the power 1. Right? This is here. For this particular area, the polynomial equation is used. Not very difficult. I am not going for the detail of the polynomial. I am just going to give some small idea. Right? In the case of polynomial, X upon M is proportional to the P to the power 1 by N. I am going to tell you about this N, and I will come to the conclusion both P is equal to 1 and P not here with this general term. This is the general expression that we use for this, and the value of N only varies. And the value of N is a specific value for any set of the adsorbent and the adsorbate. Depends only upon the nature of the adsorbate and the adsorbent. Right? So this is the quantity that depends upon. I am just going to come to this conclusion. So, right, this is the expression as it is a polynomial graph over here. Right? And here X upon M is proportional to the P to the power 0. X upon M is equal to k into p to the power 0. So x upon m, since p to the power 0 is equal to k, right? This is the way how we study the effect of the pressure on the x upon m, or the extent of the adsorption. And for this, right, इज इट क्लियर अप टू हियर? बहुत ध्यान से देखिएगा, छोटी छोटी चीजें हैं, वेरी स्मॉल थिंग्स आर देयर, राइट? एंड यू नो, इन द काइनेटिक्स चैप्टर आई टॉट यू सम प्रॉपर्टीज ऑफ द ग्राफ, and I have equated it with the graph so that you can understand it very easily also. Now you have a concept for the graphical representation, right? In the beginning, what you have seen, that the low pressure, the linear graph you have obtained, then the polynomial, and here the straight line parallel to the x-axis, right? And for this, I can write the expression like this. For the, but do you feel that it's an easy one to differentiate the graph into the so many different parts? And for everything, can you write the different expression? No, right? So it is very easy. It's convenient way to use one common equation for this, right? And this common equation, this mathematical representation has been given by the Freundlich, right? And this relationship is the Freundlich adsorption isotherm. I'm writing, can I rub this part? This is x upon m. Again, I am telling you, x is the amount of the adsorbate that is adsorbed by the m gram of the adsorbate. That means you can say the amount of adsorbate in adsorbed by the per unit mass of the adsorbent. The unit mass, 1 gram of the charcoal, how much hydrogen, how much helium or any other gas it can adsorb? This is the meaning of this, is proportional to x to the p to the power 1 by n when T is constant. The temperature is constant. This is called Freundlich adsorption isotherm. Right? Now I'm removing the proportionality sign here. X upon m is equal to k p to the power 1 by n. N is any of the integer value, and what may be its possible value, that right now I'm coming to the conclusion I'm going to discuss over here, right? For this, I think you all know what should be at the case of low pressure, the P was equal, P to the power 1 it was there. That means the value of this power was equal to 1. At high, its power was equal to 0. That means for the intermediate condition, the value of the power is not the n, the power is 1 by n here. Please remember the power is 1 by n here. This will somewhere between the 1 to 0. This will lie between the 1 and the 0, right? First condition I am discussing here, right? If the value of n is equal to 1, right? What will be your equation? K x upon m is equal to k p to the power 1. That means its value may be 1, right? When you will obtain the value 0, when you will obtain the value 0, if any quantity, the 1 is divided by the infinity, what will be its value? Generally, in most of the books, you will find that they simply write its value 0. No, it's the infinity. Whenever you divide 1 by the infinity, then it comes to the value comes to the 0. So for the last condition, that is the high pressure condition. Which condition is there? That is the high pressure condition. In that case, the value of the n will be infinity, and the value of x upon m will become kp 1 by infinity, and that will be kp to the power 0. And in all the other cases, from the lower pressure, from the beginning condition to the high pressure, when the adsorption becomes constant, the value will be any of the integer number. Right? Is it clear? So, what is a Freundlich adsorption isotherm? It is the graphical representation, right? It is the way to express the effect of the pressure on the adsorption process. This gives a relationship between the extent of the pressure with the extent of adsorption with the pressure, right? Here you can see this is called the Freundlich adsorption isotherm given for the different temperature. Here also you can see this part straight line, this part up to here straight line, then polynomial. So similar is the story here. Here polynomial, and everywhere at the end you find it becomes constant. That means it is the maximum adsorption that has already taken place. Now it is independent to the pressure change. If you are changing it, right, then what you will see, no effect will be of the change in the extent of the pressure, and this is called a saturation point. This pressure, after that, what is the saturation pressure? The pressure after that, if you increase the pressure, right, no change takes place. The saturation has already come. How much maximum it was possible? It has been done, right? And after you are going to increase in the pressure, it is not going to make any change, right? Better than discussing the result of class 10th, 11th, we must study the topic here, right? So here, this is the most important term. X upon m is the extent. Again, I am saying you cannot forget this. X upon m is the extent, right? Since it is in the unit 1, clear? And the relation is with the pressure. The Freundlich adsorption isotherm, this is the relationship between the adsorption extent and the pressure, and x upon m is proportional to the p to the power 1 by n. X upon m is equal to k p to the power 1 by n, and this n is specific for any of the adsorption process, right? Will depend only upon the nature here, right? The nature of the adsorbent and the adsorbate is good. Can we go for an experimental verification of this? We must go. Please just find out the logarithm. Right, the basic equation, x upon m is equal to k p to the power 1 by n. Now you take the logarithm of both the sides, right? Now I'm going to take log x upon m. This is equal to log k. Again, the quantities are in the multiplication, log a into log b, log a plus log b. Kinetics को याद करिए थोड़ा. Now, one more formula, I think I taught you for this, log of a to the power x. This was x log a, and this you have to apply here. Now, this will be equal to 1 by n log of P. Now, you compare it with the linear graph equation. Y is equal to mx plus c. Can I take it as the mx? No, I cannot, since k is the constant here and always in the graph and x and y axis they are taking the variables. So I have to just rearrange this equation. If I have to compare it with this, log x upon m is equal to 1 by n log p plus log k. Now, what will be the x-axis and y-axis? The y-axis will be the log of x upon m, the extent, right? Then x-axis will be the log p. Here that you can see in this graph, the x-axis is the log p, the log x upon m is taken in the y-axis, right? In the case of the kinetics, you always have seen a declined graph because there the quantities were in the minus. Every time you have seen at this point, there was one minus sign. But here, no minus sign is there, so you will get an inclined graph, right? And here, again, what is n here and what is c here? Which is slope and which is the intercept. Always the c is the intercept. So this is this intercept, this part, this is the log k, and the slope will be 1 by n. This is one very important question for the examination purpose. Whenever the Freundlich adsorption isotherm is asked, right, in that case, always the question that is asked, that question is, what is the value of the slope? What is the value of the intercept? So always and always, please do remember this. Whenever you are going to equate, I think now after learning the kinetics chapter, you have understood to analyze any of the graphical representation. Always this is taken in the y-axis. This m is the slope that you get from the graph. The x is the parameter, the variable, right, that you have. See, it is always the intercept, and you always have to compare these quantities over here, right? So this is the way how you can express it. This is the Freundlich adsorption isotherm, right? So this is the effect of different factors on which the adsorption process depends upon. The one very important topic associated with the adsorption, that is its practical application. Any topic, any chapter, any science, it is studied only because it has its value, its importance, its application in the daily life. In the NCERT book, certain examples are given, certain applications are given of this adsorption process. You have to study the one very common that you will find, the use of the silica pouch, right? It's given everywhere in the book. Simple, you have to read it, right? So here is the end of the topic adsorption, right? Just again a quick review. Adsorption, the process of depositing, accumulation, adsorbent and adsorbate, two factors, two types, physical and chemical, depending upon the bonding. And these are the certain factors: temperature, surface area, nature of the substance, pressure, right, on which it depends upon. And it has its role in our daily life. That's why the topic is taught. Thank you. Have a nice day. And please, the tomorrow class will be on the colloids, right? Please come prepared for some activities that you have studied in the class 9. To that I will start. So just be ready and come prepared for the next class. Thank you. Have a nice day.